Welcome to an introduction to linear functions and slope. In this lesson, we'll define a linear function and also determine the slope of a line given 2 points. A linear function is a function that fits the form f of x equals mx plus b or f of x equals b plus mx, where m is called the slope of the line and b is equal to the vertical intercept. We can also say a linear function is a function that can be graphically represented by a straight line on the rectangular coordinate plane. Notice how here we have the graph of several linear functions. Now let's talk about the behavior of linear functions. If as the inputs increase, the outputs also increase, we have an increasing linear function, which means the line will be going uphill from left to right. Notice here we have the graph of several increasing linear functions because the lines are going uphill from left to right. Even though some of them are increasing faster than others, all of these linear functions are increasing. If as the inputs increase, the outputs decrease, we have a decreasing linear function, which means the lines will be going downhill from left to right, which we see pictured here. All these lines are decreasing, even though some of the functions are decreasing faster than others. If as the inputs increase, the outputs remain constant, we have a constant linear function, which results in a horizontal line. Here we have the graph of several constant functions. Notice as the inputs increase, the outputs remain constant. And then finally we have vertical lines. I graphed these in red because vertical lines fail the vertical line test, and therefore vertical lines are not linear functions. We will be studying vertical lines in this lesson, but just remember vertical lines are not linear functions. When working with linear functions, we need a way to describe whether a function is increasing or decreasing, and also how fast the function is increasing or decreasing. And for this we use what's called slope, where slope is defined as the ratio of the change in output to the change in input, which sometimes we'll see written this way, where this delta means change. So again, the slope is equal to the ratio of the change in output to the change in input. And if we have a linear function in terms of x and y, which we often do, we can define the slope as the ratio of the change of y to the change of x. And then finally, if we're given 2 points on a linear function, we can determine the slope by determining the ratio of the change of the y coordinates to the change of the x coordinates. But going back to our graphs again, if the slope is positive, we have an increasing linear function, and the larger the positive slope, the faster the function increases. For example, a linear function with a slope of 5 would increase faster or go uphill faster than a linear function with a slope of positive 1/2. If the slope is negative, we have a decreasing linear function, and the smaller the negative slope, the faster the function decreases or goes downhill. For example, a linear function with a slope of -5 would go downhill faster or decrease faster than a linear function with a slope of, let's say, -1/2. If the slope is 0, we have a constant linear function, meaning we have the graph of a horizontal line. And if the slope is undefined, because we have division by 0, we have a vertical line, which again we know is not a linear function. So if we have a linear function like we do graphed here in blue, and we're given 2 points on the linear function, we can determine the slope by determining the ratio of the difference in the y coordinates to the difference in the x coordinates. This ratio gives us the ratio of the change in output to the change in input. Let's look at some examples. We're asked to determine the slope of the line containing the given 2 points. And notice how I've already graphed the 2 points on the coordinate plane and sketched the line in blue. Where here's the point -2, 3, and here's the point 4, -1. Again, because the line is going downhill from left to right, we know we have a decreasing linear function, and therefore the slope will be negative. So now we'll find the slope using our slope formula here. To keep things organized, let's label the ordered pairs. Let's call this x sub 1, y sub 1, and x sub 2, y sub 2. Before our next example, so we first have think
about
y
this
sub 2
graphically.
minus y sub 1. That would be -1 minus 3. And then we'd have x sub 2 minus x sub 1. That would be 4 minus -2. Now simplifying, Negative 1 minus 3 is negative 4. And 4 minus negative 2 is the same as 4 plus 2, or 6. So our slope is negative 4, 6. But we do have a common factor of 2 here, so this does simplify. The simplified slope is equal to negative 2/3. Notice how here we had a slope of negative 4, 6, which means when the change in the output is negative 4, the change in the input is positive 6. So notice how if we wanted to travel from this point on the left to the point on the right, we would have to go down 4 units, which is the reason why the change in the output was negative 4. And then we'd have to go right 6 units, which is the reason why the change in the input was positive 6. Also notice how when we simplified, we had negative 2/3. So notice how from this point, if we were to go, instead of down 4 units, we went down 2 units, and then right 3 units. We still find another point that would be on the same line. For example B, we have the same question. Find the slope of the line passing through the given 2 points. Again, I've already plotted the 2 points and sketched the line, where here we have coordinates negative 3, negative 1, and here we have 4, 2. Notice how the line is going uphill from left to right, which means the linear function is increasing, and therefore the slope will be positive. Let's label our ordered pairs, x sub 1, y sub 1, x sub 2, y sub 2. So the slope m is equal to y sub 2 minus y sub 1, that's 2 minus negative 1. And then we have x sub 2 minus x sub 1, that would be 4 minus negative 3. Simplifying, this becomes 2 plus 1, or 3. And here we have 4 minus negative 3, or 4 plus 3, which is 7. This doesn't simplify, and therefore our slope is 3/7. So this tells us that when the change in the output is positive 3, the change in the input is positive 7. Looking at the graph, if we wanted to travel from this point on the left to the point on the right, notice how we'd have to go up 3 units, which is why the change in the output is positive 3, and then right 7 units, which is the reason why the change in the input is positive 7. For C, again, I've already plotted the 2 points. Here's the point 3, 2, and here's the point negative 1, 2. Notice how we have a horizontal line, and therefore this is a constant linear function. Determining the slope, we have x sub 1, y sub 1, x sub 2, y sub 2. So we have m, the slope, is equal to y sub 2 minus y sub 1, that's 2 minus 2. And then x sub 2 minus x sub 1, that'd be negative 1 minus 3. So 2 minus 2 is 0. Negative 1 minus 3 is negative 4. And 0 divided by negative 4 is 0. Which you might recognize from our notes. Any horizontal line will have a slope of 0. And for our last example, we have the point 2, negative 3, and we have the point 2, 1. Notice how this is a vertical line, which means this is not a linear function. And now let's try to find our slope, x sub 1, y sub 1, x sub 2, y sub 2. So the slope m is equal to y sub 2 minus y sub 1, that's 1 minus negative 3. And then we have x sub 2 minus x sub 1, that's 2 minus 2. Simplifying, we have 1 minus negative 3 becomes 1 plus 3, or 4. But notice here we have 2 divided by 2 in our denominator, which is 0. Division by 0 is undefined. So we say the slope is undefined. Sometimes you'll see some sources say there is no slope, but we'll describe it as being undefined. And remember, whenever we have a vertical line, the slope will always be undefined, because we'll always have division by 0, because the change in the input is always 0. I hope you found this helpful.